continuing. This is part 2, I guess, for my video on differentials. So we're currently in approximation. The previous video was cut short, unfortunately. We'll continue. So again, how do you solve this kind of question? So how to approximate sine 30.85 without using a calculator? So first things first, let y equal to sine x, and then find the derivative. Derivative of sine x is cosine x times 1, or just that. So identify our y1. That's going to be what? Think of something that's very close to this. So sine, let's try 30. Sine 30 degrees. Our x1 is going to be 30. Our dx is going to be 30.85 minus 30, or 0.85, 85 over 100, 50. Let's just keep it at that for now. We can simplify later. y2 equal to y1 plus x1. Sorry. Derivative first. Cosine and then 30 times dx, which is 85 over 100. By the way, this is something that's unique to this kind of question. Whenever you find dx for trigonometric questions, I don't think this counts because this is inverse. But if it's just sine, something like sine, you have to multiply this by pi over 180. So don't forget pi over 180 right there. So 85 over 100 could be simplified as 17 over 20. (20 times 180, 3600. And how do you know what sine 30 and cosine 30 are? If you remember your unit circle, you only need the first quadrant. So just this portion. Sine 30 is, we're at 30 degrees, right? And the cosine and sine position, so it's basically going to be square root 3 over 2 and then 1/2. So for cosine 30, it's square root 3 over 2. Sine 30 is 1/2. So simplify these, you get 7,200. So that's the final answer. How about fifth root of negative 33.785? Let y equal to fifth root of x. So its derivative is going to equal to 1/5 x raised to negative 4 over 5 times 1. So how do we approximate? 30. Let's try 32. Negative 32. Don't forget the negative sign. Because we could simplify this as, never mind. Because of the negative, you can't really, because it's a different case. If it were this, you can just simply rewrite that as this. and then 2. But because of the negative sign, I don't think it's okay to simplify. So we leave it just like that. x1, that's going to be negative 32. dx is negative 33.785 minus negative 32. This becomes plus. So we have negative 1.785. So y2 approximately equal to y1 plus derivative times negative 1.785. Make this plus, put a minus sign here. Further, our answer is going to look like this. Okay, that's it. What if you want to approximate the square root of 101? So find the derivative first. y1 is going to equal to, let's try square root of 100. That's easy. How about x1? That's going to be 100. dx is 101 minus 100 equal to 1. So y sub 2 is equal to y1 plus the derivative times dx, which is 1. So 10 plus 2 times 10, 20, 200, 1. 201 over 20 is equal to y sub 2. That is the approximated value of square root of 101. Square root of 35.9. So let y equal to the square root of x. Let's try square root of 36. Something very close to square root of 35.9. Okay. Square root of 36 could be rewritten as 6 squared equal to 6. 6 plus derivative on 20. Am I in the right path? Let's check using my calculator. Only for this question, because I don't have my answer in the solution paper for some reason. Okay, so it's roughly the same. Let me show you. So this is what we got. If we place the actual problem in the calculator, they are roughly the same. Okay, what else? There is still several practice questions that I'd like to go through, but I'm tired. Let's just have this one important problem, something that's very different from what we've answered so far. So in this case, let y equal to e raised to x, and we want to find the derivative of that. It's just basically going to be e raised to x. Don't forget this. This is basically equal to 1, provided that our exponent is 1. Sorry, our exponent is x. So y1, let's try e raised to 1. For x1, try 1. dx 0.99 minus 1, 0.01, or 1 over 100. Don't forget the negative sign. Very crucial. E raised to 1 times just e raised to 1. That's it. This is the final answer. My bad. Further simplify. Okay. Word problems. I guess I'll end the video here. Word problems in another video. We'll still be applying differentials in that case.